Okay, in this problem we're going to try to walk you through the long-run profit maximization problem that was handed out as homework. The first section here is where we set up the profit equation. So on the left side of the profit equation we have P times the production function. This would have started out typically as P times Q, but we're going to maximize profit subject to the constraint of the production function. And in this problem it was Q equals x1 to the third, x2 to the third. So I've already substituted in for Q the production function, which is stated in terms of inputs x1 and x2. So profit is PQ, or P x1 to the third, x2 to the third, minus W1 x1, that's our expense on input x1, and W2 x2, our expense on x2. So we have the profit equation down here, and this will be maximized when the derivative of the profit equation with respect to input 1 and input 2 are 0. So we're going to find the derivatives and we're going to set them equal to 0. Again, you can think about this profit equation as being a three-dimensional surface that has a maximum, and when you've reached the maximum it doesn't matter which direction you take a step in. If the step is infinitely small, it should not change the height of the function, and that's the justification for looking for the x1 and x2 where these derivatives are 0. Okay, so we're going to move down the sheet a bit, and here's where we're taking the derivative of the profit equation with respect to x1, and we're setting it equal to 0. We can rewrite that by moving W1 to the other side of the equation and then isolating either x1 or x2. And we're going to isolate either x1 or x2 because eventually we have to substitute that back into the other equation, that is the derivative with respect to x2, in order to solve these two equations in these two unknowns, and the unknowns are x1 and x2. We want x1 as a function of P, W1, and W2. We want x2 as a function of P, W1, and W2. We don't want any more x1s and x2s hanging around. So we're going to isolate, in this case, x2 as a function of x1, and we'll save it and use it later. Okay. Next, we're going to take the derivative with respect to x2, set it equal to 0. Okay, and that equals this, and that should be a minus sign right there. We're going to correct that. Equals W2. Okay, so what's on the left-hand side here is, as it was before, the value of the marginal product. That is the price times the marginal product with respect to x2, and that has to equal, at the end of the day, the wage. Okay, or in this case, the price of input 2. Rearranging things will start the simplification process. I didn't make a big deal out of that before, but essentially what we're trying to do is isolate x1 or x2. Okay? Since we isolated x2 before as a function of x1, I'm going to go ahead and isolate x1 as a function of x2, okay, this time. So we're just doing repeated algebraic steps until we can get x1 by itself on one side, and it should look something like this at the end of the day. Now we can take equation 2 and substitute it into 1, or we can take equation 1 and substitute it into equation 2 and solve for the remaining unknown. So what I've done in this case is taken equation 2 and substituted it into equation 1. We have to be really careful at every step of the way that we don't mess up the fractions and we don't mess up the exponents. If we don't make any mistakes, then we'll end up with a nice clean answer. So here we have x2 equals 3 W1 over P cubed. That's this part up here. Okay, those connect up. And then we have x1 squared here. Okay, and instead of x1 squared, we're going to take our answer that we got for x1 and substitute it in for x1, and then we're going to square it. So our x1 was 3w2 over p quantity cubed. When we square that, it becomes to the 6th power, and times x2 squared. When we square that, it becomes the fourth power. So that's how we got the right-hand side of this x2 expression. Now we want to gather terms in x2. We want to get x2 all by itself on one side. So everything we do from here on out is trying to isolate x2 as a function of w1, w2, and p. Right? So initially what I did here was divide both sides by x2. So I took this expression and divided by x2, okay, and that gave me the x2 cubed on the left hand side, okay, and then I took 3w1 over p to the third and divided by that, and that gave me 3w1 over p to the minus 3 on the other side of the equation. I took 3w2 over p to the sixth and divided through by that to get rid of this part, and that gave me 3w2 over p to the minus 6 on the other side of the equation. So to get rid of those negative exponents, which I don't like, I'm going to take the reciprocal of the fractions that are inside. So 3w1 over p to the minus 3 is the same as p over 3w1 to the 3, which is how we got to this step. Okay. Now it's a matter of collecting terms in p's and w's. Okay. So I have p to the 3 times p to the 6, okay, which should be p to the 9th, okay. So I could go ahead and gather those up, make it p to the 9th. I have 3 to the 3 and 3 to the 6 in the denominator. Okay, I could gather those up, etc., etc. And then, when all is said and done, I could raise everything to the third power. But since we have nice powers here in relation to the third, so I could, before I gathered all those terms, simplify those exponents first and just take everything on the right-hand side to the third power and take this to the third power. And if I do that, I end up with x2 equals p times p squared. And that's how I get p cubed here. So in the denominator I have 3 to the 3 and 3 to the 6, but when I take the third power of that, I get 3 to the 1 power over 3 to the 2 times 3 to the 2 power, both in the denominator, and so that's how I ended up with the 27. So following that procedure, I can find my factor demand for x2. This is the firm's factor demand for x2. Notice that if P goes up, that is the output price rises, we would see the firm purchasing more of x2. If W1 goes up, that's the price of input 1, we would expect that the input for x2 would actually fall. And finally, if W2 goes up, we would also expect the price of factor 2 to go down. So in this case, it looks like there's some complementarity between these two factors. As the price of factor 1 goes up, the demand for factor 2 goes down, similar to when the price of factor 2 goes up. So what are we going to do with this? Well, we need to substitute it into 1 or 2. 2 seems easier, and then solve for x1 star. So that's what we're going to do on the remaining page. Once we follow that process and we get our expression for x1, we can plug them both back into the production function to find our output. And when we simplify, we get simply q star equals p squared over 9w1 w2, a lot cleaner than anything we've seen heretofore in this problem. This is the firm's supply of goods to the marketplace in the long run. That is the case when both factors are variable.